Hi everyone, welcome to today's lesson. We are going to talk about probability and the counting principle. So our two objectives that we're hoping to cover is one, I can create a sample space of independent events, and we'll go through different methods to create a sample space. And then two, we can use the counting principle to find all of the possible outcomes. Okay, so in class, I threw this out as a challenge of how many different outfits are possible if I have to choose between a yellow shirt and a hoodie, blue pants and black pants, and then I had these three different shoes to choose from. So how many different possible combinations of outfits are possible? Pause here if you'd like to try this on your own. Okay, so after everyone discussed, we came back together to talk about it. And we were trying to see, some people made lists, some people made a drawing or a picture of some kind to visualize it. Some people tried to figure out a shortcut method, and we kind of went through all of those together, and that's what we're going to cover in our notes today. So first off, if you remember the other day's lesson, we found the probability of one event. So for example, we found the probability of spinning a spinner one time. We found the probability of rolling a dice, of drawing a marble from a bag, of flipping a coin. Those are all one events. We're going to talk about compound events today. So two or more events happening. So for example, back to our original one, we had to choose a shirt. Okay, so that was the first event. The second event was that we had to choose a pair of pants, and the third event was that we had to choose shoes. So those were three separate events that we had to think about. Okay, so today is all about two or more events, compound events. Now, a lot of people like to have some kind of drawing to visualize what's going on. We call this a tree diagram, is the best way of doing it. Okay, so we call it a tree diagram because everything branches out. Rather than thinking about the top of a tree, it's more thinking about the roots of the tree and how it keeps spreading. So we're going to start with first our shirts. So the shirts is the first layer of our tree diagram, and we had two options. We could do a t-shirt or a hoodie. And so our tree diagram starts with our two options. Okay, our second choice we have to make is our jeans. And we had two options there. So I could choose a t-shirt with blue jeans, or I could choose a t-shirt with black jeans. If I go to the other side of the tree diagram, I could do a hoodie with blue jeans or a hoodie with black jeans. And then the third event that we have to pick is shoes. And we could do t-shirt, blue jeans, and then I have three options. So from each of these, we're going to branch three more options. We could do running shoes, high tops, or casual. Again, running, high top, or casual. Running, high top, or casual. So we have to show all three options. Running, high top, casual. To find out how many outcomes there were, we can just count the bottom row. So in this case, the shoes. If you think about it, one outfit, let me backtrack a little bit. One outfit is how you read it is t-shirt, blue jeans, running shoes. Another outfit is t-shirt, blue jeans, high tops. Another outfit is t-shirt, blue jeans, casual. If I was listing them, that's kind of what I would do. So I had three options there. So that's why we can just count the bottom row. There are three options. If I would do the same thing over here, t-shirt, black jeans, running shoes. I'd have one option, two options, and three options. So again, I could just count the bottom row there. So I have three options there, 3, 3, 3. Add up all my different outcomes. That would give us a total of 12 different outcomes, or 12 different outfits we could wear. Okay, so what we just did is we created a sample space by using a tree diagram. So this is a sample space. It shows all the different possibilities, and it's a tree diagram because it keeps branching out. Okay, so let's try to create a sample space a different method. All right, so imagine we have a cup here, and in this cup is one red, one pink, and one pink. Now the pinks are different, so we'll call this like pink 1 and pink 2. And then in this cup, the second cup, we have one red, one yellow, one pink, and one orange. And what we're doing is we're going to choose a starburst from each cup, and we're going to record all the different possibilities. Now, if I drew this pink versus this pink, that is technically a different option. So some people are like, but that's the same option, but it's different starbursts. Okay, so we want to make sure we list all the possibilities. Okay, so one way to do this, if there's only two options, two events, is to make a table. So in cup number 1, I only had 3 options. I had red, and then we called it like pink 1 and pink 2. And then cup 2, I had red, yellow, pink, orange. So to list all the different possibilities, we just combine the 2 boxes together. So I could have had a red in cup 1 and a red in cup 2. I could have done a pink and a red, and then a pink and a red. Now remember, those are different because those are technically different pinks that we drew. So even though they're the same, they're technically different because that's pink 1 and pink 2. All right, we do the same thing for red, yellow, pink, yellow, and we'd have red, pink, 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 pink again, red, orange, and pink, orange again. And to know how many different possibilities there were, we just had to count how many were in the table. So in this case, there were 12 different possibilities. Now, some students figured out that there was a shortcut, that we didn't always have to create a tree diagram or create a table, that we could instead do something with multiplying. And we called this the multiplication counting principle. So what we're going to do is we're going to find the outcomes of each event. So maybe event 1, how many possibilities there were for event 1, how many possibilities there were for event 2, and we multiply those 2 together. So let's go back to our other problems and see how this works. So back to this one, we had 2 shirts, which was event 1. We had 2 pants, which was event 2. In event 3, we had 3 shoes. Shortcut says multiply those together. 2 times 2 is 4. 4 times 3 is 12. So 12 possible options. And if we go to the starburst example, we had 3 possibilities in the first event, or cup 1. We had 4 possibilities in cup 2. Multiply those together would also give us 12 options. Okay, so this is kind of the shortcut. It's called, again, the multiplication counting principle. Sometimes you'll just hear it called the counting principle. And these can get tricky. Everybody thinks they're easy, but they can definitely get tricky. So we roll a blue and a red dice. Use the counting principle to find the number of different outcomes that are possible. So just so you guys can kind of get a visualization of this, if I would list them all, that would be, I could get a 1 and a 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on. So I could list out a ton of them. That's one option to do, or you can use the shortcut. We're going to find the first event, which was the blue dice, how many possibilities there were. So in a dice, there are 6 options. And then on the red dice, there are also 6 options. Counting principle says multiply those together to get 36 different outcomes. So if I listed all these over here on the left, I should end up with 36. All right, let's try another one. So we're playing a game. You have to spin the spinner and roll the dice. How many possibilities are there? So possibilities or outcomes in event 1 is 8. Outcomes in event 2 is 6. Shortcut says multiply together to get 48 different outcomes. All right. We're going to do this one. Feel free to pause here and try this one on your own. Oh, I'm just kidding. I skipped one. was wondering where that one went. All right, so let's do this one together and then I'll have you try the next one on your own. Okay, so if you have a keypad outside your garage door, or if you're talking about iPhones, they usually ask for a 4-digit passcode. Now, each of these digits are numbers, and they're the numbers 0 through 9. So we have technically 4 events here. We have to choose the first number, the second number, the third, and the fourth. So 4 events. My possibilities or outcomes on the first digit are 10. On the second digit, also 10. Third, also 10. And fourth, 10. Because those are the numbers 0 through 9. There's 10 of them, 1 through 9 plus 0. The counting principle says, multiply those together. There are 10,000 different possibilities for a 4-digit passcode. Okay, now go ahead and pause this one and try this one on your own. All right, let's see how you did. We have to flip a coin. That's one event. We have to then roll a dice. That's our second event. We have 2 events here. So if we flip a coin, I have 2 options. If we roll a dice, I have 6 options. Counting principle says multiply those together to get an answer of 12 different outcomes. All right, last one. This is kind of a tricky one. Mrs. Johnson has a 3-letter password to her computer. Johnny boy wants to hack into her computer and change his grades before his mom finds out. How many different possible passwords could Mrs. Johnson have? All right, it has to be 3 letters. Okay, so we have 3 blanks here, 3 events. And each event, I'm going to call this event 1, 2, and 3. Each event has to have a letter, so A through Z. If you know your alphabet, you know that those are 26 options. And the second letter could also be A through Z, so 26 options there, same as the third. Counting principle says, multiply those together. I'm going to use my calculator here. 26 times 26 times 26, or 26 to the 3rd power. That answer is 17,576 different options. All right, that is it for our lesson on the counting principle. If you remember, we have officially covered 2 different standards. We have created sample spaces, we created tables, and we created tree diagrams, and we also used the shortcut, the counting principle, to find the different number of outcomes. Please message me if you have any questions. There is homework tonight, as well as the answer key provided. All right, have a great day.